The universe's dance, orbital mechanics. I am Zoran, a dragon whose wings have brushed the fabric of the cosmos since time immemorial. I have witnessed the swirling dance of the planets as they move through the heavens, their paths choreographed by the unseen hand of mathematics. Tonight, I invite you to journey with me through the celestial waltz, the cosmic ballet that governs the movement of planets and reveals the deeper harmony of the universe. This dance, my young friend, is not just a spectacle, it is the language of the cosmos itself. The celestial waltz, the dance of the planets. The planets, those ancient travelers, spin and glide through the void of space, each one bound by the invisible threads of gravity and motion. To the untrained eye, their movement may seem random, an occasional twinkle, a shifting position in the night sky. But to the eyes of a wise observer, the planets' paths are a divine choreography, a series of arcs and spirals, crafted with precision and elegance. The ancient Greeks and Babylonians were among the first to recognize this pattern, charting the positions of the planets and creating celestial maps that were part of their understanding of the universe. The early astronomers observed that the planets did not simply wander aimlessly across the sky, but moved in cycles, each one tracing a fixed pattern in the firmament. These movements were not random, they were governed by forces unseen, but understood. The dance of the planets, however, is not merely poetic, it is governed by mathematics. The paths of the planets can be predicted with astonishing accuracy, thanks to the work of astronomers and mathematicians like Johannes Kepler, who in the 17th century formulated his laws of planetary motion. Kepler revealed that the planets follow elliptical orbits, rather than perfect circles, and that the speed of their movement is influenced by their distance from the Sun. But there is more to this cosmic dance than the laws of Kepler. The true beauty of this movement lies in the underlying geometry that governs the dance. And here, we enter the realm of Nassim Haramein's work, a vision of the universe where space itself is interconnected, where gravity and motion are not isolated forces, but part of a unified field of energy. The mathematical symphony of space. Haramein, in his exploration of the unified field theory, suggests that space is not an empty vacuum, but a dynamic, energetic medium that connects all things. The planets, as they move through this medium, are not isolated entities. They are part of a larger, interconnected system. The geometry of their orbits, whether elliptical, circular, or spiral, is part of a greater cosmic blueprint, a mathematical framework that underlies the very fabric of the universe. One of the most striking examples of this interconnectedness can be seen in the orbital paths of the planets, particularly in the relationships between their distances and the speed of their orbits. According to Kepler's third law, the farther a planet is from the Sun, the slower it moves. But this relationship is not arbitrary. It is a manifestation of the deeper, mathematical principles that govern the cosmos, principles that Haramein's work illuminates by suggesting that these orbits are a reflection of the fractal nature of space itself. In the universe, nothing is isolated. Every planet, every star, and every galaxy is connected, part of an intricate web of geometry and energy. The movements of the planets can be seen as the expression of this web, a dance of energy, where each step is carefully choreographed by the fundamental forces of nature. The fractal nature of orbits, a cosmic harmony. Imagine, if you will, the planets as dancers in a grand cosmic opera, each one tracing its orbital path like a brushstroke on the canvas of space. The more we look at these paths, the more we realize they are not random. They follow specific patterns that can be described by mathematics. The beauty of the planet's orbits lies in their fractal nature, the way they echo the same geometric patterns, whether on the smallest scale of subatomic particles or the grandest scale of galaxies. This fractal geometry, which Haramein so elegantly explores, tells us that the same principles that govern the motion of planets are also at work in the motion of light, in the structure of atoms, and even in the vastness of galaxies. The universe, it seems, is a symphony of motion and energy, where every movement is an echo of a deeper, underlying harmony. The planets move through this field, tracing their orbits, but they are also moving through time, each one carrying with it the imprint of the universe's history, the dance of the planets, and the wisdom of the cosmos. As I watch the planets glide gracefully along their orbits, I am reminded of the wisdom encoded in their movements. There is a cosmic order to the universe, one that transcends the chaos of everyday life. The planets move with precision and elegance, as if they are in tune with a deeper rhythm, a rhythm that has been there since the dawn of time. The mathematics of orbital mechanics, though complex, is not just an abstract concept, it is the language of the universe. It speaks to us of the interconnectedness of all things, of the fractal patterns that govern both the smallest particles and the largest galaxies. It reminds us that everything is connected, that the dance of the planets is not just a physical movement, but a spiritual and mathematical reflection of the cosmos itself. As we look to the stars and the planets, we are reminded of the greater dance of the universe. The planets, with their elliptical orbits and fractal patterns, are not just celestial bodies. They are teachers, offering us glimpses of the deeper truths of the universe. Through them, we learn that we, too, are part of the grand cosmic dance.